Today we will discuss a very important algorithm which is called SHA256 algorithm. It is a widely used algorithm for security purposes, especially in cybersecurity, for encrypted communication between devices or softwares. So today we will explore this algorithm. These are the header files we need to include in our project. The main function that implements this algorithm is made in separate file named as pbkdf2 underscore sha256.c. So this is the function that implements this algorithm. This algorithm is not very simple and intentionally designed. It's so complicated by making lot of shift, rotate, left shift, right shift operations, and by merging user inputs phrases with this seed key. Another concept is salt that is used to increase the complexity of this algorithm. So in fact it is very strong algorithm that is very difficult for hackers to break down this algorithm and hijack any data. Or so this is designed in such a manner to overcome all these security challenges in today's tech as well as other industries. Specifically, it is widely used in financial systems like banking systems as well as critical devices, for example, countries, missile systems, and satellite communication system that is specifically used for safety critical applications. In these things, these complex algorithms are made to overcome the security challenges, and the number of computations involved in these algorithms is very high. That makes it very difficult for hackers and other people who want to leak the information or somehow break make to wants to get into the sensitive networks or getting sensitive information. So let's go. We have implemented this algorithm here in C language. This is the main function pbkdf2 underscore sha256.c. You can find the code of this function on the GitHub, but I have implemented it according to my security phrase. The I am discussing here the core concept of this algorithm. As I already give you an idea, this algorithm is not very easy for beginners to understand. So I will give a overview of this algorithm. For the working of this algorithm, we make this function. Let me go into the definition. This is the function prototype. It takes the password, which is pointer, password length, and then sort length, iteration count, By increasing the iteration count, the complexity of this algorithm is increased very much, as well as we need a key, a key length, a password phrase entered by the user, the length of this phrase, as well as the output hash generated by this algorithm. So these are the inputs of this algorithm: 1, 2, 3, 4, 5, 6, 7, almost 7 input this algorithm takes. And by taking these 7 inputs, for example in my case it is the security phase I entered is A, which is very weak security phase. For real world application you need to enter a strong or long security phase consisting of special alphabets as well as numeric values to make your encryption more stronger and effective. That second most important thing, we will calculate the length of this security phase. Then we will there is another array which is, there is a concept of sort. This is a random array that is specially used to increase the complexity of this algorithm. For example, if someone is able to crack the security phase entered by the user, then still this random number, this sort array, when sort array is not even known to the user of that particular critical application. So if even the someone or hacker able to crack the security phase entered by the user to hack any system that is secured by SHA256, it will be very difficult for this, because this algorithm is not solely depend on this security phase. It also depends on the length of this phrase, the another random array. For example, in this case I have declared an array of uint8 type of length 4, and I made this sort array for my program is equal to its 0th index 78, first index 58, second index 08, and the third index is equal to 04, because this is the requirement for my project or my application on which I want to implement this algorithm, because the application on which I am using this algorithm has a serial number that is unique for each product of that application. So for each item, for each and every item, that serial number is different. So this serial number may be, I think, a unique feature that can be used in making the security of this device more authentic. Another thing, this sort, the array of the length of this sort array, we need a length of this sort array, and then finally we need an argument which is iteration count. More the value of this iteration count, the more complex computation this algorithm takes, the more number of times this function will be called, and this will increase the complexity of the algorithm. That makes it the hacker to crack our program very difficult or even impossible, because it is the hackers use some technique. For example, they can use dictionaries or the concept of brute force to, by applying each and every possible input to crack our algorithm. By increasing the iteration, the number of brute forces, the number of brute force attacks the hacker needs to implement to crack our algorithm will increase drastically. So that is why it is highly recommended to increase this iteration count. But there is a limitation of computational cost of this iteration count. So normally we will set this iteration count to some number in multiple of 1000. For example, in this case I am setting this iteration count equal to 3000 because my application or my computational requirements are not very high. So if I increase this iteration count, it will drastically increase the computational cost of this project, and it will consume a lot of power and memory resources of my application. So I don't want to waste many my resources on just implementing this SHA256 algorithm, because there are many other aspects of my application. So I want to utilize my resources on doing some other task as well. So this will call this function, and if you are interested, you can go through the implementation of this function by performing multiple shift operations followed by rotate operations. Mm, there are multiple. This function is a very big and complex function that is broken down into smaller chunks. So each and every chunk add another level of complexity into our algorithm. So this is the definition of this algorithm. It is not feasible to explain each and every step of this function, as it is very computationally intensive and not possible for beginners to understand each and every step. So let's run this and see what will happen. So you can, in my case, I have generated my hash, and it is a 256 bit 256 byte hash generated by this algorithm. Thank you for watching this video. If you like my video, hit the like button, and also don't forget to subscribe my YouTube channel.